Hi everyone. So there are two different kinds of forces that we are going to be talking about when it comes to atoms and molecules and how they interact with one another. So the first one that we're going to talk about is intramolecular forces. Now these are the forces that hold two atoms together. And there's actually two different kinds of intramolecular forces. And those are called covalent and ionic bonds. Those are the two intramolecular forces that we are going to focus on for this unit. So let's get right into describing both of those. Our first intramolecular force that we're going to talk about are ionic bonds. With an ionic bond, we have one atom that loses an electron, which we can see in this diagram, and we have one atom that gains an electron. When that happens, we end up with the sodium atom that lost the electron having an overall positive charge to it. The chlorine atom that gains the electron has an overall negative charge. Because they are oppositely charged because of the loss and gain of the electron, they are now attracted to each other. It's almost like magnets, where magnets, the positive end and the negative end, are going to attract to each other. And so this intramolecular force is a strong force. This bond is created between the sodium and the chlorine, and it's called an ionic bond, and it's very strong. The only way to break it apart is with some chemical reactions. So this is how salt forms. The sodium is a metal. It's on the far left side of our periodic table. The chlorine is a nonmetal. The metal loses the electron and the chlorine gains the electron, and those opposite charges cause them to bond in an ionic bond to each other. A covalent bond is another kind of intramolecular bond. Now these bonds are a little bit different. Rather than giving away or gaining electrons like in the ionic bond we just saw, a covalent bond is where the atoms actually share electrons with each other. Again, this kind of bond is going to be a very strong bond. Intramolecular bonds are very strong ones. And so this bond will help create compounds. So in this example, we see two nonmetals, or a nonmetal and a metalloid, and they are going to share their outermost electrons with each other. This is called a covalent bond, and again, this is a strong intramolecular bond that is used to create compounds. Now let's talk about intermolecular forces. This is going to be the main goal of our understanding for this unit. You do need to know the difference between intramolecular forces, the ionic and covalent bonds that happen between atoms to form compounds, and each of those different formations, how the ionic bond forms and how the covalent bond forms. But we're really going to focus this unit on intermolecular forces, and we'll go back to the intramolecular forces in the next unit. So intermolecular forces are going to be the forces in between molecules, rather than the forces within the molecule that causes them to be able to form a compound. So these intermolecular forces are pretty weak. These are going to be the forces that hold the molecule of one compound together with another molecule of the same or a different compound. They're not nearly as strong as the intramolecular forces. And I just want to point out again, the intermolecular forces are between two molecules, not within the molecule itself. So even though these particular forces are weaker than the intramolecular forces, intermolecular forces are strong enough to have an impact on many physical properties of each of the different compounds we're going to look at. So we will actually look at physical properties such as boiling points, melting points. We'll look at how quickly something evaporates, because that is impacted by the intermolecular forces. And we'll also talk about viscosity, which is how quickly or slowly a liquid flows. So intermolecular forces, sometimes they're called van der Waals attractions. They are much weaker than those intramolecular ionic and covalent bonds. So again, this is just another image pointing out for you where the intermolecular attraction is versus the intramolecular attraction. So make sure you can distinguish the difference between both of those. So I have here two models of water molecules. And so remember that those intramolecular forces are going to be the forces that hold this molecule together between the hydrogen and the oxygen atom. Now, many properties of compounds result because the molecule is what is called polar. So intramolecular forces hold these together. Intermolecular forces are going to be a result a force that holds these two together. You'll notice that they're kind of pushing apart here, but when I turn the oxygen towards the hydrogen, it grabs onto it right away. This is an intermolecular force. It's important to understand, why does this intermolecular force happen? And it's because these two molecules end up being polar. Polar means that one side of each of the different atoms has a little bit of a different charge than the other side of the atoms in this molecule. So remember, these are hydrogens, and this is oxygen. And so, because oxygen, and you can kind of tell in this model, oxygen is larger, it has more protons to it. And protons have a positive charge. And so, because this atom is larger, these guys are sharing electrons. They have a covalent intramolecular force sharing those electrons. And what's going to happen is, because the oxygen atom is bigger, it's actually going to pull the electrons that these guys are sharing with each other a little bit closer to him. And the result is that the oxygen atom has a little bit of a negative charge over here. So that little bit of a negative charge we can symbolize on our drawing. And since the electrons are spending more time over here and less time over here, the hydrogen atoms get a little bit of a positive charge to them. And that's why we call this a polar molecule. It's polar because we've got an uneven distribution of the electrons. The electrons are spending more time here at the oxygen atom to give it a little bit of that negative charge, and less time over here. And so remember that something that's positive and something that's negative attracts to each other. So this intermolecular force of these guys attracting to each other and sticking to each other is going to be because this side, this part right here, is a little bit negative, and this side right here is a little bit positive. So the fact that these are polar molecules, these molecules are going to stick to each other. And so this is called a hydrogen bond that forms right here, is a hydrogen bond. Again, it is a weak intermolecular force between them that is a result of having two polar molecules. Another type of intermolecular forces are dipole-dipole attractions. You do not need to know a definition of dipole-dipole attractions, but what you should be able to start to understand is that the strength of the attraction is going to affect physical properties. So this one has 3 boiling points for 3 different materials: propane, propanol, and propanediol. And so these boiling points are impacted by either how strong or how weak these attractions are between the molecules within all of the propane that you have. So you've got a whole bunch of propane, and it's going to boil at negative 42 degrees Celsius. That boiling point is a very cold temperature, and that's because propane has very weak electrical attractions, very weak dipole-dipole attractions, very weak intermolecular attractions to each other. So the strongest attraction is going to be having the highest boiling point. So our goal here is to understand that the stronger the attraction, the higher the boiling point. The weaker the attraction of the intermolecular attractions, then the lower the boiling point of those materials is going to be. Another kind of intermolecular force are those hydrogen bonds that I just talked about earlier with the polar molecule of water. So with hydrogen bonding, again, remember that we've got a little bit of a negative charge here on this polar molecule because it is attracting those electrons a little bit more. And we have a little bit of a positive charge here. So this is stronger than those dipole-dipole attractions. And we most commonly experience this with water. So here's my water molecule, little bit of a negative charge, another water molecule, little bit of a positive charge, and they are attracted to each other. This is going to result in what is called a hydrogen bond. So the two of these kind of being attracted to each other is called a hydrogen bond. It's a result of the polar molecule. A little bit of negative, little bit of positive. And so this results in water having some interesting properties. When it is a solid, it is less dense because the spacing in between these molecules actually gets bigger as they're a solid. And when they're a liquid, that spacing actually comes a little bit closer and they flow past one another a little bit more. So because it's less dense, so they're a little bit farther apart, that is going to result in ice being able to float. And that's important so that organisms down at the bottom of lakes and rivers and ponds don't die as the water solidifies all the way through. Another interesting property that results from this is surface tension. Surface tension, we're going to see in class, is going to be, again, a result of this hydrogen bonding, where we kind of get the formation of bubbles. And we'll talk about that, like if we put some droplets of water on a table, kind of forms like a curved bubble. And then also, hydrogen bonding is going to help with what is called capillary action. So remember that if I've got these water molecules in the ground and they've got to be pulled up into the stems and all the way up a tree, the fact that these guys are attracted to each other, they're going to kind of help pull each other up. So as one molecule gets pulled up, they kind of pull the rest of them up because of this attraction that they have. The other reason you have to know hydrogen bonds is because, interestingly enough, we see hydrogen bonds as being important in a lot of other things. For example, there is a hydrogen bond in your DNA holding together the adenine and thymine that make up that center portion of your DNA. Hydrogen bonding is also important in the shape of proteins. And you might remember from biology that the shape of proteins is important because the shape has to fit in the correct way in order to make those chemical reactions happening. And then actually paper glue is the way that paper glue works is actually a result of hydrogen bonding as well. As the glue dries, there are more hydrogen bonds that form. And so then the glue hardens and it keeps everything stuck together. The last kind of intermolecular force are London dispersion attractions. You do not need to know specifics about this one. You should just simply know that London dispersion attractions is another intermolecular attraction or force. And so that's again going to be between the same molecules being attracted to one another.